Okay, this video will cover redox reactions. We will do one example right here. This is the example that we had in class. Remember, a redox reaction happens when you have a change in oxidation numbers from the reactant side to the product side. We'll go ahead and do number one, and then we'll move down the list. We'll see if the oxidation number changes for any of these. Whichever one has an oxidation number decrease or increase will be the one that the question is asking us for. So if we start off with number one, we have a hydrogen cation plus a hydroxide anion, and then we have that giving us H2O. The rule that I gave you in class was that an element that is free or by itself will have a zero charge. What I forgot to mention was that if it has a charge, then you would have to give it an oxidation number that equals that charge. So yes, this is hydrogen by itself, but because it has that plus charge, its oxidation number would be +1. If we move on to hydroxide ion, we can give the oxygen that -2, the hydrogen can have that +1. If we add these numbers, -2 + 1, that gives us that -1 charge, so our oxidation numbers are good there. Now let's see if the oxidation number changed for any of these elements. We have hydrogen over here, right? We would give it a +1 charge. Oxygen would have its -2 charge. Now let's calculate these. If you have H2O, and the hydrogen has a +1 charge, there's 2 hydrogen atoms, so we would have a total charge of +2. Oxygen is -2, our compound is neutral. It didn't have a charge to begin with, so we're good here. There is no change in oxidation number. The board kind of messed up on that. So we have +1 here for hydrogen, +1 over here for hydrogen. Oxygen, we started off with -2. It still has a -2 oxidation number. So that one is not a redox reaction. If we look at number 2, we start off with hydrogen, we end up with hydrogen. Those two do count as free elements because they do not have a charge. Therefore, we start off with a 0 charge, we end up with a 0 charge. So that is also not a redox reaction. If you look at number 3, you start off with a solid, you end up with a liquid, right? But those are just water. You start off with water, you end up with water. You just change the phase. That's just the phase change, so it's just a physical change, not a chemical change. So it cannot be a redox reaction. So no change in oxidation number there. Now, looking at number 4, we have 2 hydrogen peroxide molecules. So I have 2 H2O2 in liquid form, and we have 2 water molecules left over in liquid form. And 1 oxygen molecule in gas form. For my oxidation numbers, I'll go ahead and start here. Hydrogen will have its +1 oxidation number. We can give oxygen its -2, but remember that this is one of the exceptions where oxygen does not get the -2. Normally we would assign it here because it's in the 6A group. Anything in the 6A group would have an oxidation number of -2, but hydrogen peroxide is the exception. Let's find out, or let's see why. If hydrogen has a +1, and hydrogen almost always has a +1, then here we have a total of 4 hydrogen atoms. You have 2 in 1 molecule, but we have 2 molecules overall. So 2 times 2 is 4. That would be a charge of +4. Then we have oxygen. We have 2 oxygens, but then we have 2 molecules with 2 oxygens each. So 2 times 2 is 4. We multiply it times our -2 oxidation number. That gives us a total of -8. Now, if you notice, that compound was neutral to begin with, so its oxidation numbers have to add up to 0. If we keep these oxidation numbers, they give us a +4 and a -8. That would be -4 overall, and that's not what we started with. So instead, what we can do is give this oxygen its -1 charge, or -1 oxidation number, and then 2 times 2 is still 4, times -1 would be -4. These two cancel out, so our oxidation numbers are good there. We move on over here. We have H2O. So again, give your hydrogen is +1. Oxygen will be -2. Hydrogen, we have 4 hydrogen atoms here. So times +4 is going to be +4. we have 2 oxygen atoms. 2 times -2 will be -4. So we're good there with our oxidation numbers, +1, -2. This is a free element, so its oxidation number is 0. Hydrogen started off with a +1 oxidation number. It still has a +1, so that's good. Oxygen, however, as you can see, its oxidation number went from -1 to -2. Okay, so that means that our oxidation number for oxygen was reduced. So we had a reduction right there in the oxygen, and therefore this right here is going to be our reduction reaction.